A bridge is a structure built to span a valley, road, body of water, or other physical obstacle, for the purpose of preventing passage over the obstacle. Designs of bridges vary depending on the function of the bridge and the nature of the terrain where the bridge is constructed. Bridges are structures that connect urban settlements to improve the exchange of products and services between these, and at the same time to giving to a people a better quality of life. This structure provides many benefits in the economy through trade and other social and political aspects. According to the stress distribution in the structure, there are 4 types of bridges. The beam bridge. The beam bridge is the simplest of all bridges. Consists of one horizontal beam with 2 supports or pillars, usually on either end. These freestanding bridges are usually built as a functional walkways or just for decoration. About this last, we can see that they commonly built from cedar, pine, and redwood. Beam bridges are also made of steel, or a mixture of steel and concrete. They often are made in sections or boxes, where they are attached at the side of the bridge. The boxes are made of steel and concrete, or just concrete. Arch bridge. Arch bridges are among of the oldest types of bridges and have been around for thousands of years. Arch bridges have great natural strength. They were originally built of stone or brick, but these days are built of reinforced concrete or steel. In this type of bridge, the width is carried outward along 2 curving paths. The points where the arch reaches the ground keeps the bridge up because they resist the outward thrust. The roadway is located on the top of the arch. Suspension bridge. In a suspension bridge, cables which are suspended by towers which supports them hold up the road deck. The width is transferred by the cables to the towers, which then in turn transfer the width to the ground. Cable stayed bridge. This bridge is similar to suspension bridges because cable supports the roadway. 2 or more towers have cables hanging from them. This cable supports the roadway by transferring the width to the towers. In turn, the towers transfer the width to the ground. The construction of a cable-stayed bridge is similar to the construction of a regular suspension bridge, except on how the cables are positioned. Cantilever bridge. This bridge depends on counterbalance, that are weights used to balance another weight. They consist of 2 or more arms that equal balance each other, almost like a perfectly balance. Often the part of the bridge that leads to the first cantilever is just a beam bridge. Cantilever bridges are built with many materials in different ways. Some use one arch to connect the arm, others just have arms and a roadway, and cables that work like a cable-stayed bridge. Cantilever bridges are built in a way similar to beam and arch bridges, depending on how the bridge is designed. So after this introduction about what the bridges are, their difference in materials, their design innovations, and their importance for development of communications, I will refer to a specific bridge that caught my attention for its unusual design. Alameda Bridge. The Alameda Bridge is located in Seville, Andalusia, Spain, and allows access to the Olympic Stadium and to La Cartuja, an island between the canal and the Guadalquivir River. It was designed by Santiago Calatrava in the period of 1987 and 1992 as a part of the new and innovative constructions presented in the Expo 1992, the Universal Exposition of Seville, which then was the Age of Discovery. 3 other bridges were built for the exhibition, one of these also designed by Santiago Calatrava. The initial project was intended that the island of La Cartuja remain united in its 2 ends by 2 twin bridges of great visual impact. giving the feeling of crossing a single bridge, uniting in its two edges. However, this initial project was completed only by the bridge in the channel from the city, and 526.5 meters viaduct that would connect the two bridges due to financial problems. The Alamilla is a steel cantilever spar cable stayed bridge. It is a modern variation of the cable stayed bridge in the form of a harp that extended by 260 meters of length. For its construction, it was used one of the largest cranes in the world, capable of lifting 200 tons in 160 meters of height. The design of this bridge consists in a single mast or pylon of 140 meters of height, which supports the entire weight of the board of the bridge through a pair of suspenders. It's considered the first bridge supported by cables in which the platform is balanced by the weight of the tower titled. Between the mast and the board there is a balance of forces which acts on the 13 pairs of suspenders of 300 meters of length. In terms of materials, we can see in this picture that the mast or pylon was made by hexagonal steel plates reinforced with concrete inside. The board is designed with a metal structure and consists of a central triangle and hexagonal shaped anchors where the axis of the straps. Along the Alamilla Bridge is located the viaduct of La Cartuja, a length of 526.5 meters long and supported at its end on embankments reinforced by stirrups, with the stair and access platforms. It is a dome structure with continuous rails cantilever superpoints on reserve for traffic vehicles, about 22 meters wide, and two ladder for pedestrians and bicycles of 4.40 meters each. Finally, besides the global recognition as one of the most impressive and innovative bridges, one of the most important achievements of the construction of this bridge is the establishment of a primarily urban connection that served as a milestone in technological development, achieved an example of prior art construction in the country.